With section 1 in unit 15, it was over water and its properties. We were all familiar with water and exactly what water is, but we needed to identify its properties and make it more clear to us. So some important wording was surface tension, which is the low inward force or pull that tends to minimize the surface area of a liquid. So when the surface of a water, let's say, is about to break, or when something's floating on water, what makes it float is the surface tension. And then we have surfactant, and that is any substance that interferes with hydrogen bonding between water molecules and then reduces the surface tension. So this is when the surface tension is being reduced, and say something might sink or break or fall through the water. So when we're learning about the properties of water, and we learn what makes this unique and substance essential to life on Earth. So that's how it relates back to properties and dealing with what we do in everyday life. So many unique and important properties of water, including its high surface tension and low vapor pressure, result from the hydrogen bonding, which is something we may not think of. So the structure of ice is a regular open framework of water molecules arranged like a honeycomb, which, like that picture or that snowflake, would be considered a honeycomb. So extensive hydrogen bonding in ice holds these water molecules farther apart in a more ordered arrangement than in liquid water. This reflects the structure of an ice crystal, like being shown. Then we move to section 2, and we learn more about the homogeneous aqueous system. And in this, we're finding which types of solutions conduct electricity. So we're just moving more into depth with water systems. So the aqueous solution is water that contains dissolved particles, and those are called the solute. So those kind of go hand in hand, the aqueous solution and the solute. And then we move on to the electrolyte, which is a compound that conducts electric current when it is in an aqueous solution or in the molten state. So kind of like the picture to the right, everything is being transformed and all these steps and factors are happening in that. So then the non-electrolyte is when a compound that doesn't conduct an electric current in either an aqueous solution or the molten state. So that's just completely the opposite. So a solvent dissolves the solute, and the solute becomes dispersed in that solvent, which may sound confusing, but when we did our labs and stuff, it all made sense. So all ionic compounds are electrolytes because they dissociate into ions. So they break down into these things called the ions. And as individual solute ions break away from the crystal, the negatively and positively charged ions become surrounded by solvent molecules and the ionic crystal dissolves. So like in the picture, ions are breaking down and the crystals are being dissolved. So when writing the formula of a hydrate, we use a dot to connect the formula of the compound and the number of water molecules per formula unit. So that's just kind of a little tip or a little helper. So moving on to 15-3, we learn about the heterogeneous aqueous systems. So in this, we learn that the characteristics of colloids are like a related mixture called suspension. So in learning about suspension, a suspension differs from a solution because the particles of a suspension are longer and they don't stay suspended indefinitely. And then a colloid have particles smaller than those in a suspension and larger than those in solutions. So that's kind of like opposite. You gotta be smaller than the suspensions but larger than the solutions. And then the last one, an emulsion, is a colloidal dispersion of a liquid into a liquid. So that's what an emulsion is. So when reviewing this chapter, there are key concepts that we need to keep in mind when working with the water system. So right here at the bottom left-hand corner is a key equation, which if you're doing problems, You will be using that a lot. So percent H2O equals the mass of water divided by the mass of hydrate times 100%. And that will get you your answer in most cases. So the high surface tension and low vapor pressure of water are the results of hydrogen bonding, which we talked about. When the water is strong and when the water is weak of the surface. And the structure of ice is a regular open framework of water molecules held together by hydrogen bonds and arranged like a honeycomb or a snowflake. And the molecules in liquid water are packed closer together than they are in ice, which is something I did not know. So then moving on, in a solution, a solvent dissolves the solute, and the solute becomes dispersed into the solvent. When you think about that, you realize that that makes a lot of sense, and it doesn't seem as hard as it sounds. And then in the dissolving process, individual solute ions break away from the crystal. Solvent molecules surround the negative and positive charged ions in a process called solvation, and the ionic crystal dissolves, which also makes sense when the molecule is surrounded by negative and positive, then it will obviously just dissolve and go away. So when a suspension differs from a solution, you got to think about this because the component particles of a suspension are much larger and they don't stay suspended. And colloids have particles smaller than those in suspensions and larger than those in solutions, which is review and just something important that you want to keep in mind throughout this chapter.